Hello guys, it's Miss Garcia. Welcome to Math City with Miss G. In this video, we are going to talk about similar triangle applications. It is about word problems. We are given in number 1, triangles EFG and QRS are similar. And then we are also given with the lengths of triangle EFG. The length of the smallest side is given, and that is 280 for QRS. And what is the length of the longest side? So for us to, this problem is too wordy, so let us draw a diagram to help us set up our proportion. So we're going to start with triangle EFG. Then the other triangle is QRS, and let's label the measurements of triangle EFG. We've got 144, 128, and 112. The length of the smallest side of QRS is 280. So I have to find the smallest side of the other triangle. And the smallest side in this, it's not drawn for accuracy, just to do a representation, but this is the smallest number. So I have to place the smallest side of QRS on this side of the triangle. So they correspond to each other. Now, what is the length of the longest side? So with this information, I have to find the longest side of the given triangle, EFG. So that is EFG, and this is 144. So I have to place the unknown to find segment QR, or this side of the triangle, and represent that with a letter. I'm going to use X. And so now we can set up the proportion. We can start with 144 over X equals 112 over 280. Cross multiply, so this will give us 112X equals, we're multiplying 144 times 280. So 112 equals 144 times 280 is equal to 40,320. We divide both sides by 112, and so X is equal to 360. So 360 is the length of the longest side of triangle QRS. Let's try another problem. By the way, if you find value in this video, please hit subscribe, as that will help my channel. Thank you so much. Let's try number 2. This time we're given with two triangles that are similar, IJK and TUV. We're given with the sides of triangle IJK, and we are asked to find the perimeter of the other triangle. So let's draw the figure IJK and the other figure. Again, these figures are drawn to help us visualize the problem. It's not drawn for accuracy. So the length of the sides of triangle IJK are 40, 50, and 24. The length of the longest side of TUV, so that means I have to find the longest side of the other triangle, and that is 50. So for TUV, the longest side is 275. So I have to write 275 on this side, because these two sides of the triangle corresponds to each other. They're similar. They're proportional. So what is the perimeter? So we have to find the perimeter of this triangle. So 40 plus 24 plus 50, adding these numbers, that will give us 114 And for the other triangle, that is the unknown. It says what's the perimeter of TUV, and we don't know that information. And so therefore, for perimeter of TUV is unknown, I'm gonna replace that with an X to represent the perimeter. So we now can set up our proportion. There's multiple ways to set up the proportion. One way is I'm going to start with 50 over 275 equals the perimeter of the given triangle where all sides are given, and then X where we're trying to find the perimeter. So by the way, there are 3 methods that you can solve the problem, this specific problem. So another method is to find the two other sides of the triangle, this side right here and this side right here, and then you add all the sides. That's one method. You could also find the scale factor and then multiply. So that's another method. This is one method that I'm showing you. So let's continue. Cross multiply. 50 times x is 50x, and 144 times 275, that is equal to 31,350, dividing both sides by 50, so x is equal to 627. 627 is the perimeter of triangle TUV. Let's try another problem. On a sunny day, Bill wants to find the height of a tree. He walks 25 feet along the shadow that the tree casts until his shadow ends at the same point as the tree's shadow. So let's draw a tree that represents the illustration. So Bill is standing right here, and so his shadow and the tree kind of overlap. So in this problem, he walks 25 feet, so this is 25 feet. Bill's height is 6 feet, so I'm going to place 6 feet, and Bill's shadow is 9. So this portion right here is 9 feet. So this would mean that the base, we are going to add from here to here. We're going to add these two together, and that would make 34. And since we're solving for the height, we're going to represent this part of the figure with a variable. I'm going to use x. So if this is so complex, we could split the figure to make it a little simpler. So we could split this by making a small triangle to represent Bill's information. We've got 6 feet here and a 9, and then the other triangle is going to be a little bigger, and so the bottom is going to be 34 and the other side is going to be x. That's the height of the tree. So if this is helpful to you, then go ahead, split the figure, because it helps us set up our proportion. Okay, so I would like to set up my proportion by starting with 6 over x equals 9 over 34. Let's solve the problem. So we have 9 times x is 9x, and multiplying 6 times 34, that would be 204. Okay, we divide both sides by 9, and that is equal to, it's a decimal, so if you got a decimal, you are right, 22.66. This is repeating, so we could use 23. This is going to be 23 feet is the height of the tree. But if we go back to the problem, it is asking us how many inches tall. So therefore, we are going to do an extra step, and that extra step is to convert 23 feet into inches. So 1 foot is equivalent to 12 inches, and so canceling the unit feet, multiplying 23 times 12, that is equal to 276 inches, and this is the height of the tree. All right, let's do one more problem, and that problem is about Louisa. She began walking up a hill at a spot where the elevation is 0.9 kilometers. After she walked 3 kilometers, she saw a sign giving the elevation as 0.95 kilometers. So I'm gonna draw like a hill, and this portion here is going to be 0.9 kilometers. So that means she started already in a hilly portion of the hill. So she walked 3 kilometers, so from this portion to here is going to be 3 kilometers. She saw a sign giving the elevation as 0.95, so that's this portion. So instead of writing 0.95, remember she started at 0.9. So we are going to do 0.95 minus 0.9, which gives us 0.5. So this is 0.5. Now she continued walking, and then we're trying to figure how much she has walked until she saw or reaches 1.1. So this portion here, that's when she saw 1.1. But instead of writing 1.1, we are going to do 1.1 minus 0.9. And this is equal to 0.2. So this is 0.2. And this is the unknown. The question is, how far has she walked when she reaches an elevation of 1.1? So this would mean that the whole thing is what is being asked. So we are going to do 3 plus x. But before we get there, we need to find the value of x. So if this figure looks too complex, we can split this into 2 triangles. One triangle, the small triangle, is going to be 3 and 0.5. The bigger triangle is going to be 0.2, and right here is going to be 3 plus x. So let's set up our proportion. We can start with 3 over 3 plus x equals 0.05 over, oh, hold on 1 second. I am so sorry. This right here is 0.05. Yes, so, I'm sorry, I stand corrected. So that is 0.05. And so then this one right here is 0.05. Apologies. Okay, now that is corrected. Now let's move on. So this number right here is going to be 0.2. We're going to do cross multiplication just like what we did. Cross multiply this and this. So we have 0.05 times 3 plus x and 3 times 0.2. So distributing 0.05, that would be 0.15 plus 0.05x equals, multiplying this two, that would be a 0.6. And then we're gonna subtract 0.15 on both sides. 0.15, and this will leave us with 0.05x equals 0.45. Okay, so isolating x, we're dividing both sides with 0.05, and so this will give us x is equal to 9. So the value of x is equal to 9. But remember, we are trying to find how far she has walked. So that would be 3 plus x, which is 3 plus the value of x that we found, 9. So then therefore, Louisa has walked for 12 kilometers when she reached the elevation of 1.1 kilometers. Alright, thank you for watching this video. See you in my next one. Bye.